So here they're asking us to solve for different things in the problem. Here in the first case, we're going to be asked to solve for a change in G. And the second thing we're going to be asked to solve for a change in S. Now, the equation that guards these all together is change in G is equal to change in H minus T change in S. And these are all under standard conditions. But yeah, so I could put these zeros here. Now, we're asked to solve for G. So we have to look through the information and see what they actually give us in the problem. And right off the bat, they give us our H, which is 172 kilojoules. And it's really, really important here to make sure that you note what units you have. And then we're going to subtract from that, and this is also really important. They give us a temperature of 63 degrees Celsius. So whenever we have a temperature in Celsius, we have to add 273.15 to get to our Kelvin temperature. So we're going to go ahead and do that, and when we do, through the magic of having done it off screen, we end up with a temperature of 336.15 Kelvin. And then they tell us our S is 512 joules per Kelvin. Now, what's kind of nice about the way they've set this up for us is that when we're doing this, we can cancel out units that are the same. So here we have Kelvin and Kelvin. So the unit we have here is joules, and the unit we have here is kilojoules. And this is sometimes a problem for students. So I'm going to do this in two steps for us here. Step number one is I'm going to convert everything into kilojoules. So we have our change in G is going to be equal to 172 kilojoules, and then we're going to multiply these two things out. We're subtracting. We're going to multiply this by this, and when we do that, we're then going to convert it in the next step to kilojoules. So let's do it first in joules. We have 1.721, and we could put more significant figures if we want to, 1 times 10 to the 5th joules. Now, as a reminder, if we know the number of joules we have, 1.7211 times 10 to the 5th joules, we can say for every 1,000 joules, there's 1 kilojoule. And when we do that, we can convert this by essentially dividing this by 1,000, sliding it over 3 places. And when we do that, I'm going to take this whole little bit right here, and I'm going to move it out of our way for just a second. When we do that, when we convert that, we're going to end up with let me do this here. We're going to end up with 172 kilojoules subtract 172.11 kilojoules. Now, if you do the math on those two things, this is 172 minus 172.11. We typically want to keep as many significant figures to the very end. We're going to end up with a negative 0.11 kilojoules for our change in G. So that's going to go right here. Negative 0.11 kilojoules. Now, I'm going to get rid of this right now all over here. Not very well, of course. And then we're going to take a look at the second part of this problem, which is this right here. Now, if you notice here, we haven't really cared very much about the equation because they did all the heavy lifting for us. They told us the change in H. They told us the 32 kilojoules. They did the same thing up here. They figured that out for us. Now, what they could have done if they wanted to be more evil is they could have given us a table and we'd have to figure out the change in H using the table, and the same thing for S. But they didn't. They gave us that information, so we're going to say thank you. Now, again, we're going to use the same exact equation. Our change in G equals change in H minus T change in S. Again, I've eschewed writing the at standard conditions. And if we isolate this and isolate S by itself, what we're going to end up with is essentially change in H minus change in G all over T is going to be equal to our change in S. And so then all we're going to have to do is plug in the values they've given us, again, being wary that the S that we're looking for is in joules per Kelvin. So let's take the numbers from the magical off-screen calculator. And first, we're going to put in our change in H over here. So I'm going to move this over to here. And I'm going to write our change in H is negative 12 kilojoules. All of that is going to be subtracting what our change in G is, which is 32 kilojoules. And all of that is going to be over our change in temperature. Now remember, we already calculated our change in temperature previously, and it has to be in Kelvin, so we're going to go 336.15 Kelvin. In both these cases right now, when we do the math on it, not both these cases, but when we solve it out, our change in S is going to be equal to negative 0.130893. I'm keeping all the numbers in here because I can, but that unit is going to be kilojoules per Kelvin is equal to my change in S. The problem is that we cannot keep it in kilojoules. We have to convert it to joules. So I'm going to go over here and I'm going to essentially know that a kilojoule is equal to 1,000 joules. So we're going to multiply this number by 1,000 and we're going to end up with negative 130.893 joules per Kelvin. Now, one of the things that I failed to do originally is go up in the problem, and they asked the second part of the question, and they said, is it spontaneous? And what we know to be true is this always. When the change in G is negative, the reaction is always spontaneous, right? So this reaction here is spontaneous. Over here, when we look at the data, and I could take this number right here, the negative 130, and put it up here. So since I have the ability to use cut, I'm going to take this, all of this right up here, and I'm going to put it in this space right, put it in this space right here, negative 130. I know this is a disaster, but what I do want to look at here is the change in G. They ask whether or not the reaction is spontaneous. If our change in G is positive, this reaction going this direction is not spontaneous. But we know if a reaction is not spontaneous in one direction, it is spontaneous in the other direction. So we know that the answer in this case is that the reverse reaction is spontaneous. Hopefully this has helped.